Models of quadratic functions. Let's have this activity one. The bottle battle. In a carnival, a popular game, bottle toss, have bottles arranged as shown. You are asked to choose your level to toss. However, bottles in level 4 and 5 are not yet arranged. Help me find out how many bottles should I need for level 4 and level 5. Observe the pattern and draw level 4 and level 5. The sequence in the first row is odd numbers. So for the first row on figure 4, we have 7 bottles. Second row, 5 bottles. Third row, 3 bottles. And the fourth row, 1 bottle. So a total of 16 bottles. And the fifth figure, 9 bottles. Second row, 7 bottles. Third row, 5 bottles. Fourth row, 3 bottles. And fifth row, 1 bottles. A total of 25 bottles. Use the table to represent the number of bottles. We let X for level and Y for the number of bottles. So, level 1, we have 1 bottle. Level 2, we have 4 bottles. Level 3, we have 9 bottles. Level 4, we have 16 bottles. And level 5, we have 25 bottles. Now, what equation describes the pattern? As you can observe from the table of values, if you are going to square x, then it will give you the value of y. So we have y is equal to x squared. Graph the relation using the Cartesian plane on the right. So this is 1 and 1, 2 and 4, 3 and 9, 4 and 16, 5 and 25. Then connect the dots. How will you describe the graph obtained in the activity? That is something to do with the models of a quadratic functions. For our learning objective, identify quadratic functions, model real-life situations using quadratic functions, and demonstrate appreciation of using quadratic functions in modeling real-life situations. For our essential questions, how do quadratic functions facilitate finding solutions on real-life problems and in making decisions? Let's have this problem as one of the applications of quadratic function. Mr. Santos wants to enclose the rectangular parking lot beside his house by putting a wire fence on the three sides. If the total length of the wire is 80 meters, find the dimension of the parking lot that will enclose a maximum area. Number 1. If you represent one of the side as x, how will you represent the other side adjacent to it? Number 2. Write the quadratic function that models the area of the parking lot. Number 3. Write the equivalent quadratic equation of the function and identify the values of a, b, and c. Number 4. To get the desired dimensions, use the formula x is equal to negative b all over 2a, then solve for y using the obtained value of x. What you have seen is not a linear function but an example of a quadratic function, the graph while ago. Quadratic function is any function of the form y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Consider using table of values to graph the function y is equal to x squared. Now, plot the other points on the same Cartesian plane. So if we have 0, then the value of your y is 0. If x is equal to negative 1, then the value of your y is 1. If negative 2, 4, negative 3, 9, negative 4, 16, and negative 5, 25. And plot, we have 0, 0, negative 1, 1, negative 3, 9, negative 4, 16, and negative 5, 25. Then connect the points we have. Then, how will you describe the graph? It is a U shape, right? A curved line. And the graph of quadratic function is a smooth curve called a parabola. Let's have this activity too. Identify me. Which of the following real-life models represent a quadratic function or a linear function? Letter A. The graph of throwing a ball at a height h for a given time t defined by the function h is equal to 3 plus 14t minus 5t squared. Is that a quadratic function or a linear function? Very good. That is a quadratic function. Letter B. The graph of duration of phone calls per minute m at a given cost c represented by function m is equal to c plus 10. Is that a quadratic function or a linear function? Very good. That is an example of a linear function. Letter C. The graph of bike company's profit P gained at a given cost C represented by the function P is equal to negative 200C squared plus 92,000C minus 8,400,000. Is that a quadratic function or a linear function? It's obvious into the graph, right? You're correct that that is a quadratic function. Now, let's answer this question. How did you classify each of the given functions? Number 2, how do a quadratic function and a linear function differ? For your activity 3, quadratic or not, which of the following equations represents a quadratic function? Letter A, y is equal to 2t squared minus 7x. You're correct that is a quadratic function because it's degree 2. Letter B, x is equal to y minus 34. Is that a quadratic function or not? Definitely not a quadratic function. Letter C, y is equal to 5x cubed minus 7 plus 3x. Very good, that is not a quadratic function because the degree is 3. Letter D, f of x is equal to the quantity of x plus 3 times the quantity of x plus 4. You are correct. If you are going to simplify that, it will give you degree 2. So that is a quadratic function. What makes a function quadratic? Your activity 4, quadratic function, identification challenge. Please visit the quizzes and take this activity. Let's have your activity 5, parking lot problem. Mr. Santos wants to enclose the rectangular parking lot beside his house by putting a wire fence on the three sides. If the total length of the wire is 80 meters, find the dimension of the parking lot that will enclose a maximum area. Number 1, if you represent one of the side as x, how will you represent the other side adjacent to it? Number 2, write the quadratic function that models the area of the parking lot. Number 3, write the equivalent quadratic equation of the function and identify the values of a, b, and c. Number 4, to get the desired dimension, use the formula x is equal to negative b all over 2a, then solve for y using the obtained value of x. Let's represent the problem in figure. This part will represent the house, and this is the parking lot. Question number 1. If you represent one of the sides as x, how will you represent the other side adjacent to it? So this side is x and this adjacent side is 80 minus 2x. So let x be the length of one of the two equal sides in meters, and 80 minus 2x be the other side opposite the house in meters. P of x be the area of the lot in a square meter. Write the quadratic function that models the area of the parking lot. Take note, area is equal to length times the width. And we say area is denoted as P of x. So we have P of x is equal to x times 80 minus 2x, which is the length and the width of the rectangle. P of x is equal to x times 80 is 80x. X times negative 2x is negative 2x squared. Arrange that in standard form, we have negative 2x squared plus 80x. Then the value of a is negative 2, b is 80, c is 0. To get the desired dimension of the form, use the formula x is equal to negative b all over 2a, then solve for y using the obtained value of x. So the values of your ABC are negative 2, 80, and 0 respectively. So substitute it into the formula. X is equal to negative b all over 2a is equal to the value of b is 80 all over the value of a was negative 2 times 2. Simplify it, we have negative 80 all over 2 times negative 2 is negative 4. Simplify that, we have negative 80 divided by negative 4 is positive 20. Then solve for the other side by using this expression 80 minus 2x. Substitute the computed value of your x, which is 20. That is equal to 80 minus 2 times the value of your x is 20. Simplify, 80 minus 2 times 20 is 40. 80 minus 40 is 40. What is the meaning of 20 and 40? So it says here, while ago, that x represents the length of the one of the two equal sides, and 80 minus 2x be the other side opposite the house in meters. So we can now answer the question, find the dimensions of the parking lot that will enclose a maximum area. So, therefore, the dimensions that will enclose the parking lot with a maximum area are 20 meters by 40 meters. Now, going back to our essential question, how do quadratic functions facilitate finding solutions on real-life problems and in making decisions? For activity 6, quadratic case. Quadratic functions show a polynomial equations with degree blank of the form blank or blank, where a, b, and c are real numbers and a is not equal to blank. So what is the degree of the quadratic function? It's 2. And it can be written as y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c. So a, b, and c are real numbers and a is not equal to 0. Let's have this question. How do you personally model honesty in your actions and interactions as a student? For your quiz, letter A, state whether each of the following situations represent quadratic functions. Number 1, the area A of a room with length 3 meters more than the width. Number 2, the price P of a meat per number of kilograms and at 220 pesos per kilo. Letter B, identify if the graph represents quadratic function. It's number 3. Number 4. And letter C, state whether the equation represent a quadratic function or not. Number 5, y is equal to 3x squared minus 2. For your assignment, answer activity 3, identify me on page 127.